I'm going to be showing you today how to graph an exponential function. So recall from first semester, it was a few units in, you were asked to graph functions that looked something like maybe this one at the top, y equals x squared minus 5. So if you forget kind of how we did that, we basically just made a table of values and then we plotted the points. I don't know if you guys remember, but when it's x squared, remember that it's a parabola or a U shape. Maybe you remember talking about, oh, if there's a negative out front, it would be upside down. This one doesn't have it, so it's a regular U. Hopefully that like rings a little bit of a bell, but to graph something like that, you probably just made a little T-chart, a little table. Your teacher probably told you, at least I told my students if you had me, the 5 values that I picked for x was always -2, -1, 0, 1, and 2. And then just one at a time, I plugged those numbers in for x, right there, to get the y values that went with it. Realize that anytime you're asked to graph something, like if it's mx plus b, we know a lot of shortcuts for that. We plot the b value and then we count the slope. But realistically, if you're ever asked to graph a function, get the picture of it, what does it look like, you can always resort to making a table. So just kind of keep that in mind. But here, when I plug these numbers in for x, so I'm going to stick them in right there where x is. Remember that you always have to use parentheses around a number when you plug it in. So I'm going to do -2, that's my first x value, squared minus 5. We've learned this unit that it makes a difference whether the parentheses are there, especially on squared. But I would just plug it in exactly like that into my calculator, and I would get a y value of -1. I need to get some other points, so I always say you got to pick negatives so you see what the function looks like over here. 0 is easy to plug in, and then pick some positives so we see what it looks like over here. Make it easy for yourself and just use your calculator to do the work. So now I want to plug in -1, so I just arrowed up and I'm going to go over -2 and I'm going to plug in -1 for x, which would give me -4 for y. I'm going to arrow up and delete the 0, so press DEL, and then just put 0 in. Same thing, arrow up, put in 1, and then put in 2. So once you've got a table of values here, just recognize that these are ordered pairs. So I can just plot, this is just 5 ordered pairs, I can plot these points and then connect them. And hopefully mine works out to be a U shape. So the first ordered pair is -2, -1, so that's left 2, down 1, then -1, -4, 0, -5 would be right there. Perfect. And what do you know? There's my parabola. All right, so essentially all we're doing today is graphing. It's not something with a squared. Instead, it's going to be exponential functions like we looked at last time with exponential growth and decay. Realize again though, you can always make a table if you're asked to graph something. So that's what I'm going to show you first. And again, we must do the same thing with exponential functions. We need to make a table, get some ordered pairs, then we're going to plot them and connect them, and we've got our graph. I am going to show you a shortcut. Yay. Obviously, if I don't have to make this table and do all that work, that's ideal. But that's not that bad, so I'm going to start by showing you that way. But on the back, I will show you a little shortcut, but I want you to understand why the shortcut works before you just straight use it. A table of values always works, every time. A lot of times on iStep, you'll be asked to graph stuff, so if you forget a shortcut here and there, even a shortcut for mx plus b, you could always make a table of values and plot the points. Useful stuff to know. So I want to graph each exponential function by making a table of 5 points. Now, again, last time we learned exponential functions have the form, the general form, y equals ab to the x. Okay, so remember that from last time. We talked about exponential growth and decay last time. So maybe I go in and analyze these two functions in that way. Remember that the a value was the initial value, what you start with, and what was in parentheses, the b value, that tells you if it's growth or decay. So if you kind of think about that, we said that if the b value was bigger than 1, like this one is, then it was growth. And if the b value is less than 1, like it is on example 2, that's 1/3, then it's got to be decay. So that's something smart to think about, because that can help you decide what the shape of the graph will look like. But I don't know much more than that, so I'm going to just go ahead and make a table off to the side here for both of these. And I'm still going to stick with -2, -1, 0, 1, and 2. I'm going to do the same thing on this one, so let's go ahead and get that table started. You got to pick some negatives, you got to pick some positives, so you see what it looks like on either side of 0. And then just pick 0 because that's super easy to plug in. All right, let's do the growth one first. So I can use my calculator. You definitely want to use your calculator. It makes it so much easier. And just one at a time, I'm going to plug these numbers in where x is. So I'll write what you should put into your calculator for the first y value here. So 4 parentheses 2, and raise it to the x power, which I'm going to use -2 first. Plug it into your calculator exactly like that, parentheses and all. So my first y value is 1. I don't like to retype the whole thing, so I just arrow up and scroll over. Now I want to put the exponent as -1 instead of -2. Then I get 2. Delete the negative, put in 0, and then 1 and 2. If you need help with this part, just ask me in class, and I would be happy to kind of help you figure out how to plug all this in. Most of you have this calculator though, so just follow what I'm doing. Now I've got 5 ordered pairs, so I'm just going to plot the points here on the graph and connect them. So the first one is -2, 1. So that's left 2, up 1. -1, 2. Watch kind of how they're counting here. This is kind of weird on the x-axis. They're actually counting by 0.5, so it's kind of like spaced out a little bit. 0, 4 is there. 1, 8 would be here. And 2, 16 is going to go way off the graph, but it'd be somewhere up there. All right, here's how you connect these. So this is kind of weird. Let's see how smooth I can do this. Now, that was pretty good. Not the best curve, but it should be like a nice smooth curve. Notice, and I only did this part because I know this part because I'm really smart. Just kidding, I've done these before. But it actually does not cross the x-axis, and I'll show you why in a minute. So don't just go like straight down with it, like down here. It should curve off and kind of follow along the x-axis. Again, I'll point that out in a minute though, but just draw your curve like I did. And then let's go ahead and do number 2 before we kind of look for any patterns or anything going on here. So I'm going to plug in the same x values. Use your calculator. So I'm going to do 9 parentheses 1/3. You could do 1 divided by 3, same difference. Then caret, I'm going to plug in -2 first. Okay, so we'll write it out here. One at a time, plug them in. My first y value is 81. Pretty sure I'm not going to be able to graph that. Hopefully the others are more manageable. Not much better, but getting there. You plug in -1, you get 27. When you plug in 0, there we go, I get 9. When I plug in 1, I get 3. And when I plug in 2, I get 1. Okay, so let's plot these points. Now, I'm not even going to attempt to plot the point -2, 81, because it's obviously like way off my paper. Even -1, 27 is way off my paper. So the first point I'm going to be able to plot is 0 and then up 9, right there. 1, 3, 2, 1. It's the same kind of shape. It's just like a smooth curve, except this one And it's decay, so it makes sense, guys. It's kind of going down as x gets bigger. Put arrows at both ends to show it goes on forever. So notice they look the same, they just go in different directions. And that makes sense because we already analyzed that the first one was growth and the second one was decay. So this one, as x is getting bigger, the function is getting bigger as well. It's growing. This one, as x is getting bigger, it's getting smaller. Hence why it's decay. All right, let's look a little bit closer here. There is a pattern going on. So again, I want to point out real quick how I mentioned that the graph never crosses the x-axis. If you think about the decay one, it kind of makes sense why. So let's talk about money. You know that the A value is your initial value. So let's say that you like start with $9 and the rate is 1/3. That basically means that like somebody takes 1/3 of your money every day. We'll say that. So like, okay, if I have $9 and someone takes 1/3 of it, well, I would just like divide it by 3 every time. So I would start at like $9 and then after one day, I would have 1/3 of it left. I would have $3. After 2 days, I would have $1. After that, I would have like pennies and more pennies and more pennies. Basically, if you just take 1/3 of my money every day, eventually I'm just going to have like a fraction of a penny left. I'm never going to actually have $0. I'm just going to have like a piece of a penny. So like as the days go on, my money just gets less and less and less and less, but I actually never go into the negatives. I'm just going to have like barely any money left. So that's why it kind of like never crosses down here into the negative values. It just gets closer and closer to 0. Okay, whether you follow that a whole lot or not, I just want you to notice, and here's what we do. You'll do this in Algebra 2, but I'm going to draw like a dashed line here. Same thing over here. And I'm going to draw it over the x-axis. These exponential functions never cross the x-axis. If you have a line on a graph that your like curve never crosses, it has a name. It's called an asymptote. It's spelled really weird. Asymptote. Again, that's not something you learn until Algebra 2, but now maybe you'll have seen that word before, and when your Algebra 2 teacher mentions it, you'll be like, oh yeah, I've heard that before. An asymptote is just a line that a graph never crosses. Kind of random. You are all smarter for knowing it now. All right, let's figure out the shortcut. So question down here says, what do you notice about the A value on each of the 2 previous examples? Well, check it out. The A value, if I'm thinking AB to the X, that's the first number. So in this case it's 4, in this case it's 9. Look at the graph. So let's look at the y-axis. Look where 4 is. Look where 9 is. Maybe you notice that the A value is actually the y-intercept. It's where the curve crosses the y-axis. So here's the y-axis, curve crosses at 9, curve crosses at 4. So that's really important to pick out if you're going to use any type of shortcut. So let's put where the curve touches the y-axis. That is the first thing we need for a shortcut. Yay! On the back. Okay. A value is the y-intercept. Exactly what we just said and what we just noticed. So that's going to get you a point on the graph. So maybe I go down here and let's try using the shortcut. Keep in mind, you can make a table of values if you don't want to use this shortcut. That's totally fine. I'm just showing you maybe a quicker way if you're the type of person that likes to remember that. Okay, so if I was going to graph number 1 using a shorter method than making a table, I would notice, hey, the A value is 3. So that means that my curve crosses the y-axis at 3. So I have a point here, and I know the curve's either going to look like this or like this. You need to get more points on there, though, than just that, so that way it's an accurate graph. So that's why we need another shortcut, so we can get some more points on the graph. The A value tells you something, the y-intercept. The B value, and again I'm thinking like y equals A times B to the X. the B value is going to tell you what to multiply by as you move right, or as x gets bigger, and as you move left, or x gets smaller, the B value tells you what to divide by. That's a whole lot of words. I'll show you what it means down here on the two examples. That part's definitely more complicated than the y-intercept part. That part's pretty easy. It's shortcut number 2 that might cause you a couple of hang-ups, that might make you decide to just do a table, but you totally pick how you want to do it. Before I show you what that means, I do want to point out the shapes here. So we saw it on the front. If it's growing, it's going to go up. If it's decaying, it goes down. So in general, your graph on these is either going to look like one or two of these pictures. Okay, it's one or the other. So this one's growth, it's going up. As x gets bigger, it's going up. This one, as x gets bigger, it's going down. So the curve goes down, that's decay. So it's either going to be one or the other. Think about it before you get your graph going, because if it goes the wrong way, you can adjust it. So if I kind of think about these two, I see on example 1 that the B value is bigger than 1. So I know that this has to be growth. So it should look like this picture. It should go like this. And then this one, the B value is smaller than 1, so this one has to be decay. So it should look like this picture. All right, let me show you what shortcut number 2 means. So the B value on this case is 3. This is going to tell you what you multiply by as you shift right on your graph. So you start at the y-intercept, we put that on there, the A value. As I shift right 1, or as x gets bigger, I'm going to multiply where I started here, my y-intercept, by this B value, which is 3. And basically, let's say you start with $3 and you're going to triple your money every day. So I'm just multiplying 3 by 3 to start. 3 times 3 is 9, so as I shift right, I got to go and I got to put a point at 9. I would multiply again by the B value. So let's see, 9, now I'm at 9. 9 times 3 is 27. So as I shift right, that would be my next point. But it goes way off the graph. So I'm just going to stop with the 9 there. You want to figure out what your graph looks like to the left as well. So as I was shifting right, I multiplied by the B value. So as I shift left, I do the opposite and I divide by the B value. Okay, so go back to your y-intercept. I'm at 3. So to shift left, I'm going to divide that by 3 every time. So 3 divided by 3 is 1. So shift left and plot a point at 1. 1 divided by 3 is a third, so shift left and plot a point at 1/3, which is going to be like obviously between 0 and 1. And it would just continue to get smaller and smaller every time, but it would never cross the x-axis. So when you go to do your curve, and on your exam, you should not let your curve cross the x-axis here. Okay, it should just follow along. If you cross the x-axis on the exam, I'm going to take some points off. So be careful. Okay, over here, so I put all the shortcut together. Here's what I do. The A value on this one's 2, so that's my y-intercept. This is decay, so I know the shape goes like this. As I shift right, I multiply 2 by the B value. Okay. You can use your calculator if you need to. But guys, 2 times 1/2, I hope you can figure out that that is 1. Okay, so 2 times 1/2 is 1. So I multiply as I shift right. So my next point would be 1. 1 times 1/2 is 1/2. So I would shift 1 again and plot a point and 1/2. The second you get to like between 0 and 1, just stop. You know it's going to get closer and closer to 0. As you shift left, so I was multiplying by 1/2 as I shift right. So as I shift left, I divide by 1/2. Okay, so I'm at 2, and I have to divide that by 1/2. You can do your fraction rules by hand, you can use your calculator, but if you divide by 1/2, you should get 4. So as you shift left, go to 4 and plot a point. basically you just are multiplying by 2. If you remember, like keep, change, flip, dividing by a half is the same thing as multiplying by 2. So if I'm at 4 and I multiply that by 2, I get 8. So as I shift left again, I'm at 8. I go off the graph from there, so I'm just going to draw my curve. And there's my graphs. So you pick which way you want to do it. Sometimes the shortcut can be a little bit more confusing than anything, but you can either do the shortcut or you could always just make a table. Totally up to you.